Analyze the particulate diagram. The illustration depicts a highly ordered, repeating two-dimensional lattice composed of alternating positively charged ions, plus, and negatively charged ions. This structure is the classic particulate representation of an ionic crystalline solid. Explain the mechanical property, brittleness. When a mechanical stress, force, is applied to an ionic crystal, layers of ions shift slightly. This shift brings ions of like charges into direct alignment with one another, positive next to positive, negative next to negative. The resulting strong electrostatic repulsion causes the crystal lattice to cleave and shatter, which is why ionic solids are highly brittle. Explain the solid-state conductivity properties. In a solid ionic lattice, the cations and anions are locked into rigid, fixed positions by strong electrostatic forces. Because there are no mobile charged particles, neither free ions nor delocalized electrons, to carry an electric current or rapidly transfer kinetic energy, ionic solids are poor thermal and electrical conductors. Explain the solution phase behavior. Electrolyte. When an ionic solid dissolves in water, polar water molecules disrupt the crystal lattice via ion-dipole attractions. This dissociation frees the ions, allowing them to move independently throughout the liquid. These mobile ions can conduct electricity, making the dissolved solution a strong electrolyte. Match properties to select the correct option. Combining these properties, brittle, water-soluble electrolyte, and a poor conductor as a solid, identifies option C as the correct description of the solid. The correct answer is option C. It is a brittle, water-soluble electrolyte that is a poor thermal and electrical conductor as a solid.